Now this is just a reminder, in that last video, these graphs were discrete points, isolated points, and when we write their domain and their range, they're a list of specific single x's and single y's. So in this section, D, E, and F, you can see this time our graphs are continuous because they're in solid lines. And if we have continuous graphs, when we write their domain, we're going to have to write them with an inequality because we want to show that all of the numbers in between the left and the right are included in the domain. All right, so these are all three continuous because they are solid lines as opposed to separate points. The domain for this first one, so again, I'm going to write that with an X such that, and then on this one, we're going to write it as a three-part inequality because it's going to go, our X's are going to go from our smallest one, which is right here. The first X that's pointed is right here at -2, so we're going to start with a -2. It's equal because you can see the solid dot, so it's going to be less than or equal to X. Remember that when we do this three-part inequality, our inequalities always point to the left, and then this is going to be less than or equal to, and then the rightmost, the last X value that's plotted is this one right here, which is at 4. Then we do our Y values to look for the range. We're going to go from the bottom to the top. So here, we'll have Y such that, and that gets a little bit tougher because you like to think left to right, but it's got to be bottom to top. So as we plotted the points, the lowest point plotted is this one, and it has this Y value right here. So it has a Y value of 0. This point is the top one that's plotted, and it has a Y value of 3. So in between all of these right here are plotted in between 0 and 3. So this is going to be 0, and again the dots are closed in, so less than or equal to Y, because it's the range, is less than or equal to the highest Y value graphed, would be a 3. Okay, so now let's look at example E. Again, we've got the solid line. I need to determine for my domain the X values. So the one that's the smallest is the furthest to the left, and that X value that plotted this point would be -3. So our domain is going to be all X's such that I'm going to start with that -3. It's a colored in dot, so that means it's included. So I put less than or equal to X. And then this time, the one that's the furthest to the right, so the last X that's plotted is an open dot. So I'm just going to make this be a less than, and that X value that's plotted there is a 3. All right, then for our range, we're going to do all Y's such that our bottom Y that's plotted, the lowest Y that's plotted appears to be -3 right here. So -3 is less than or equal to Y. And again, the top one is with the open dot, so it's just going to be less than. And the top Y value that's plotted is right here at 1. So 3, and this is a Y value of 1. This third one, example F, our domain then is all X's such that, again, let's say our leftmost X is this right here, which was a -2. You got to look and think about what was plotted. So I went over -2 and down to get that spot. So the X is -2. It's an open dot, so it's going to be less than X. It's less than, again, an open dot. And to get that dot, it looks like I went over a +2 and down. So 2 for that. And then for the range, the lowest one, or both of these are these outputs. It looks like the output for these, Y such that Y, oh, I don't want a Y there, do I? I'll make that go away. I'm going to have my lowest Y that's plotted, it's going to be -1. That's going to be less than because those are open dots. Y is less than, oh, is that less than or equal to? Is there an open dot there? No, there's not. So they're not going to put a big nasty looking, colored in dot right there. It's just going to be a smooth go through. If there's not an open dot, that means that this is included as well. So it's going to be less than or equal to 3, less than or equal to 3.